Hello everyone, welcome to the Innovation Hub module. My name is Arzamam. Today we'll be walking you through what operating systems are, but our main focus today will be going through and discussing about the different components, the very essential components that make up the operating system. So let's get started. So let's introduce you to the kernel. Now, what is the kernel? The kernel is basically the core component of an operating system, and it basically acts as the central control system of any computer. It is responsible for managing communication between the software application and the hardware of a device or a computer. Uh, Whenever a user runs a program, the kernel ensures that the program receives the necessary resources such as the CPU, memory, and access to the hardware devices that is present in your computer. So, because of the function that it carries out, the canal basically plays a essential role in maintaining the stability, efficiency, and the performance of your computer system. One of the main responsibilities, one of the main functions of the canal is to effectively manage its resources. It manages the processor by deciding which programs to run and how long should these programs be run for. To and this is done to basically ensure there's a fair CPU allocation. It is also responsible for the handling of the memory management by assigning RAM to different applications and preventing them from interfering with each other basically. Additionally, the kernel manages the communication of a device, allowing the hardware components of your computer like your keyboard, the printers and the storage devices, which are the hardware examples, to function properly through device drivers. The kernel also basically ensures system security and reliability. It restricts unauthorized access to your hardware components like the keyboard we've discussed before, and protects the system processes from harmful applications by controlling how programs basically interact with the system. The kernel prevents crashes and maintains a smooth performance. Modern operating systems such as the Microsoft system, the Microsoft Windows operating system, the Linux operating system, and the Mac OS, the Mac operating system, they all very much depend on the kernel to manage their system operations effectively. Without the kernel, the operating system would not be able to function properly, making the most essential component of your device. Uh, um, it makes it extremely essential. It makes the kernel as a component extremely vital to the function for the performance of any computer or device in general. So, on this note, we'll move on to process management. So, process management is a key function of an operating system, and it basically is responsible for running the programs on a computer. For example, a process is any program. For context, what is a program? A process is basically a program currently being executed on a computer, such as a browser, music player, or document editor. The operating system manages these processes to ensure that multiple applications can run smoothly on your device, on your computer, all at the same time. One of the main roles of the process management is the CPU scheduling, where the operating system decides it basically decides which process gets access to the processor, which of the who gets access to the processor, and basically for how long. This allows a user to perform multitasking on the computer, enabling users to perform activities like I've said before, like browsing on the internet, listening to music, and downloading files simultaneously at a fast rate, for example. The operating system quickly switches between processes to maintain efficient performance on your device. Process management also controls the creation, execution, and determination of different processes. It ensures that system resources are used efficiently and it basically avoids and prevents conflicts between the different programs that are running on your device or computer, for example. By managing all of these processes simultaneously and effectively, the operating system maintains its stability, it maintains its efficiency, it improves performance, and it ensures overall its main objective is to provide uh, all of you a good user experience. Let's now move on to memory management. Memory management is a fundamental function of an operating system that controls how a computer's memory is used. It is responsible for allocating and managing RAM. So, what is the full form of RAM? It is random access memory, so that different programs can run simultaneously, and not just simultaneously, it can also run efficiently. Whenever an application is opened, for example, your browser or a music application, the operating system assigns a portion of memory to it. So, if, for example, it's got a it's got a fixed amount of memory, it's going to assign a specific portion. It's going to assign a specific chunk of memory to that's the specific program that's running on your computer. So basically, to do this, the operating system creates separate memory spaces for different applications, which helps the system maintain stability and prevents crashes on your computer. It also tracks, which areas of memory are being used and which ones are exactly available. Which basically enables the system to allocate and to optimize its resources effectively. Allowing this, okay, this ensures that multiple applications such as your browsers, your video games, document editors can run simultaneously without any performance issues or a potential crash. When the system runs low or on RAM, memory management, it uses virtual memory, which temporarily uses storage space as additional memory. So although virtual memory is can can be proven to be slower than the RAM, which is random access memory, it basically helps the device, it helps the computer which you're using maintain its performance, maintain the levels, and also more importantly, it prevents programs from crashing down or from closing effectively. By managing memory effectively, the operating system basically ensures that the users are able to effectively multitask on a device. It improves the performance, improves stability, and it basically maintains the reliability and the user experience overall. Okay, now let's move on to file management. So the file system management is a key function of an operating system that controls, exactly how data is stored, organized, and how it is retrieved from your device or a computer. It creates a structured system of files and folders, which basically enables users to store documents, images, videos, and applications in a proper, organized way. This structure makes it easier for users to locate and manage their data effectively. One of the main responsibilities of this file system management is to handle operations such as creating, deleting, moving, copying, and renaming files. The operation system also keeps track of where each file is stored, where, okay, what is the location. It basically keeps track of the location where exactly the files are located, where it is stored on the storage device. Basically, and the function of this, the purpose of this is to ensure that the users are able to access the files quickly, and to ensure that the users are provided with a reliable access to the files that may contain information and data. This allows the users to open files instantly without having to know effectively where the files, where the exact physical conditions, exact physical location of the file on the disk. The file system management also plays an important role in the security and data protection. It basically controls the files permissions. It ensures that only authorized users are able to view and access the files. It also gives authorized users permission to even edit and modify uh, those exact same set of files. Additionally, it basically prevents the corruption of data, and it effectively manages storage space, like we've discussed before previously. By basically organizing data in this manner, by organizing data effectively, and by maintaining the security of the file system basically ensures a smooth system performance, reliable data management, and overall enhanced user experience. So now let's move on to your device management. Device management is a key function of an operating system that controls and basic effectively it coordinates all of the hardware devices connected to a computer. These devices, they include your input devices such as your keyboard, your mouse, your mice, and your output devices like your monitors and your printers, which are your output devices. And storage devices such as USB drivers and external hard disks, which are also your output devices. The operating system or your OS basically ensures that all of these devices they're effectively able to communicate properly with each other. They're able to coordinate, with the computer, and they're able to function efficiently. Device management also ensures that hardware resources are used efficiently and without conflict or without having them crash or shut down. It controls how multiple devices they're able to operate simultaneously. They are able to coordinate with each other. They're able to communicate, and how they're able to operate and multitask simultaneously and prioritize tasks when necessary. By managing hardware, communication, and performance, device management helps maintain system stability and ensures the smooth enhanced interaction between the user and the device. So now let's discuss a little more on user interface. User interface, it is one of the key critical components of your operating system, which basically enables you, the user, to communicate with your own device or your computer. It basically acts as a bridge, between the user and the system that they're operating, which enables users to perform various tasks such as opening applications, opening files, managing those exact same files, and controlling system settings on your device. Without a user interface, unfortunately, users would find it extremely difficult to communicate with the computer and to even perform basic tasks and different functions like we've touched upon previously. The So basically there are two types of user interface. You've got the graphical user interface, which is your GUI, and you've got the command line interface, which is a CLI. The graphical user interface uses icons, windows, menus, and buttons, which basically makes it easy. It makes it easy for users like you to navigate the entire system using just a touchpad, using a touch screen, and using a mouse. In contrast, the command line interface basically enables the users to type in commands into the computer directly, which is basically used by programmers on a daily basis and system administrators for more advanced options, for more advanced controls. Last but not the least, let's discuss about the real life applications of OS or your operating systems. It is used in every devices such as your computers, smartphones, your tabs, and on huge servers to manage, hardware, which is the hard components of your system, and it basically runs applications. Its purpose is to run applications and files efficiently. For example, operating systems like Microsoft Windows, Linux operating system, the Mac OS we've discussed before. Um, it basically allows you users to browse the internet, to create documents, to run music, and to basically handle and interact with different programs, which basically helps you to multitask in your everyday work life. Um, Similarly, if you're talking about smartphones, they also use operating systems like like the Android operating system to manage apps. It's built in with touchscreen input and device performance. Operating systems are also widely used in businesses, schools, uh, work office, and in data centers to manage multiple users and to basically organize and interact with billions and billions and large amounts of data. Servers rely on operating systems to handle network communication, security, and your cloud services. Without operating systems, unfortunately, modern devices would not be able to function efficiently. The software application of any device would not be able to effectively coordinate with the hardware component of the device, and it would be difficult for users like you to interact with the device, to run applications, or to communicate with the hardware and networks of present in your device. So thank you very much. Thank you very much for sticking around to the very end. This is the end of our module, and I'll be meeting you later here at Innovation Hub. Thank you very much.